So, in this module, we are discussing on volumetric analysis. So, what is volumetric analysis? Yes, as it is written, it's the determination of volume of solution required for complete reaction with another solution whose volume is known. So, here we can take an example. By looking on example, you will get what it is. That is simply if a determination of volume of HCl required for complete neutralization of 20 ml of 0.1 NaOH means that is actually it is the determination of volume. Okay, so one application of volumetric analysis is titration. What is titration? Yes, as we have discussed in our previous video, we know what is titration. Titration, it is the determination of concentration of an unknown solution using a standard solution. And when you are coming on titration, what is equivalence point, end point, that's all we have discussed. Then also we know about what is a standard solution, then titrate, titrant and everything regarding that. Now then we have also discussed what are primary and secondary standards. After that we have types of titration. Yes, coming on to the types of titration, we have three major or different types of titration, which is neutralization titration, redox titration and complexometric titration. So what is neutralization titration or acid base titration? We will discuss first that. Okay, coming to this neutralization titration, we have acidimetry and alkalimetry. So what is acidimetry and what is alkalimetry? Acidimetry, it is the estimation. As acidimetry means here the standard solution is acid. Alkalimetry, the standard solution is alkali. So in alkalimetry, taking alkali as a standard solution, we determine the estimation of acidic solution. Okay, yes, now that is what alkalimetry and acidimetry is. Now coming to indicator. Indicators are substances which helps to understand or to get the end point. Sometimes when you are looking different types of titration, one which you have already done maybe what permanganometry, that is using KMnO4 and oxalic acid. There KMnO4 act as a self indicator. But some cases that self indicator is not there, so we use certain indicators. So acid base indicator means these are the substances. Apart from that, coming back, acid base indicators are substances which shows different colors on acid and base. Okay, so if we take if we take this as an example, actually these are organic acids, weak acids and weak bases. Okay, so in the text we have two examples to be looked, that is phenolphthalein and methyl orange, where phenolphthalein is a weak organic acid and methyl orange is a weak organic base. So if we take the indicator phenolphthalein, in pH of 8 it is colorless, and when it shifts to 9.5 it is pink color. Okay, at equivalent point, that is equivalent point is a point at which actually end point is the very next point of equivalent point. Equivalent point is a point in which the molecules get completely react with each other, leaving the end point as the very next to equivalent point. So now theory of acid base indicators, if we look on the theory of acid base indicators, it shows different color on acidic and basic solution firstly. Then acid base indicators are either weak acids or weak bases. In text we have two examples, which is phenolphthalein and methyl orange. So if we take this, so Ostwald's theory, according to Ostwald's theory, let us consider HPH as colorless, which is we are writing HPH, which is phenolphthalein. Okay, this is phenolphthalein. When this dissociate, we leaves pH minus and a H plus. Okay, when this dissociate, it leaves pH minus and H plus. This pH minus is pink color. Okay, So this is how we can determine the end point. So if it is present in HPH, it is colorless, and when it shifts to H minus, it's pink color. Similarly, methyl orange, which is a weak base, so we can write methyl orange as MEOH. Since it is a base, we write OH. Since this is an acid, we represent H. Okay, it donates hydrogen H. So here MEOH, which is methyl orange, which is yellow color. At the end point, this get dissociated to Me plus plus OH minus. So this Me plus is red color. So this marks the end point. So if we are detailing on this particular phenolphthalein with example, that is, we want to we are considering NaOH in a beaker. We take NaOH in a beaker, then we add this phenolphthalein into this. So according to Le Chatelier's, as we know, NaOH liberate OH minus ions, right? So that OH minus and the hydrogen liberated or getting from this particular phenolphthalein get combined to get water, leaving pH minus, which is pink color. So what it states that equilibrium shift towards right. At the first case, when it forms water, equilibrium shift towards right. And coming in, when we take HCl here instead of NaOH, here water is not formed. So what happened? Equilibrium shifted towards left, which means here it leaves colorless, because we know HPH is colorless. So when water is liberated, that is pH leaves behind. So the end point will be marked by pink color. When we take an acid instead of base here, instead of NaOH, in the second case when we consider HCl, what happens is the end point will be marked with colorless. That is what because the Le Chatelier's principle considers equilibrium shifting towards right and left. Here why it shift towards right? Because similarly methyl orange also. Methyl orange in the case of methyl orange in NaOH, it forms a yellow color because MEOH is leaving. Equilibrium is shifting towards the left. Methyl orange yellow. When we take acid, what? The equilibrium shift towards the right, giving red color. So if we write in exam point of view, if you want to define what is acid base indicators, these are substances which are used to detect the end point in an acid base titration, since they have the ability to change color with the pH. That is the point which you should mention, because that's the reason why you choose acid base indicators. The two examples were given in your text is methyl orange and phenolphthalein. Phenolphthalein is a weak acid, methyl orange is a weak base. The pH variations, that is when the pH goes down to from 3.1, methyl orange shows red color. This range should be known, okay? This is important. Yes. Now Ostwald's theory. An acid base indicator is either weak organic acid or weak organic base. Acid type, it is phenolphthalein. Equation is represented there. Then base type, it is methyl orange. Here also equation is. Just to note, it's just the note what we have discussed since far. Now these are the types of acid base indicator. That is strong acid, strong base, weak acid, strong base, weak base, strong acid. Anyway, weak acid, weak base, it is not there, because which we will discuss, okay? And because weak acid, in case of weak acid, weak base, no rapid change in pH can be determined. Only if there is a rapid change in pH, we can find the end point using certain indicators and all. We can discuss this in our next video. Seems this to be extending for 9 minutes, so we can see the types of acid base titration in our next video.